Okay. Yeah, I have little issues with this because does anybody here have a Windows computer and they ask you to like upgrade to Windows 10? And then some things that you thought you had out there now not quite sure where they're at, or and I did this like in the middle of the day on Saturday. I was like halfway through some things, and I kind of did it to myself. Shouldn't have done it. I mean, I really was not that expert on Windows 8, and 8 was the one that was like such a big change from 7, and then I went to 10. But live and learn. You could teach the old dog new tricks. So distributive and dividing. Again, things that you kind of know already. I mean, what's different about it now is that we're using real numbers, which means the negatives get opened up, fractions, decimals, things like that, or more so than you might have done in the past. So distributive property. This is showing us distributive property. It gives you the formulas here, and then it shows you examples here. The thing to keep in mind about distributive property, which you're probably used to seeing more like this example, 3 parentheses 4 plus 2, is the multiplication can be on either side. Right? It doesn't have to be on the left side of the parentheses. You know, notice the way that they handle. There's 3 parentheses 4 plus 2 is 3 times 4 plus 3 times 2. When they multiplied on the right, they made it 3 times 2 plus 5 times 2. So that 2 was being multiplied in each term on the right. I think sometimes, because we see it so much on the left, we're not sure that it's okay to do it on the right or how to do it on the right. What if you don't like multiplying outside the parentheses on the right? How could you fix that? What property could you invoke? Commutative, right? You could just switch the order. If you don't like it being multiplied on the right, then switch the order of the multiplication. That's a property that we've got. And now you are multiplying on the left. Okay. So, and you can even see the first they had the product of A and B plus C, and then it's a product of A and B minus C. So they're trying to just show negatives can be involved, minuses, subtractions can be involved. It actually gets more complicated. Where we make all of the mistakes with distributive is when the number you're multiplying by, in this case the A, is negative. That's the thing that causes us trouble. Not so much the negative or minus sign which is inside, but the minus sign which is outside. Okay. So here's some examples of them using this. Now you could tell, notice the difference between these examples and the examples on the previous slide. The examples on the previous slide were all numbers. There was no variables involved at all. I mean, truthfully, if I was given examples like these on the right, there is nothing that stops me from just adding the numbers inside the parentheses, right? That, in fact, that's probably what I would do. 4 plus 2 is 6. 3 times 6 is 18. Okay. Here, because there's variables in there, you can't do that. So you really do have to show all the distributive property. Now, anything in particular confusing here? The first one, 4 times y plus 3. 4y plus 4 times 3, which is 12. How about the b and c? When you're multiplying by a variable, you know, are we clear with that n times n is n squared? Right? Because what does it mean to square something? We multiply it times itself. So when we multiply the n times n, we get n squared. When we multiply the n times negative n, we get minus 9n. Right? Same way up here. Now we're multiplying by the y on the right. But again, when you do y times y, it's y squared. A lot of times when I'm doing these operations, I actually draw the zeros myself. That's the way I would do it, just to be straight with what I'm multiplying. So why don't you try? Obviously, you're going to have to do this. Try the, let me see what the next one is. We are going to do just 2 of them. We're going to do number 1. We're going to do number 4. What did you get in the first one?
2x plus 6.
2x plus 6, right? 2 times x plus 3 is 2 times x plus 2 times 3. 2x plus 6. 2n times a half, 6 times a half. Okay, what is 2n times a half? Yeah, again, think when you got a 2 in the denominator and a 2 in the numerator, cancel them, and that's just n. You don't even need to write the 1n, right? Because why?
Because it already has 1.
Because 1 times anything is the same thing. So we don't write a 1 as a coefficient if we don't need it, right? And then the 2, what about the 6 times a half? It's 3, right? Just write it as a 3, plus 3. So the only difference between what we just did and these examples is that now they're using negatives. So notice that if you multiply negative 2 times x plus 7, that negative 2 is going to change the sign of both terms. And that is, you know, all the way through calculus, something that we just keep making mistakes on over and over again. Right? This negative 2x, everybody gets that. But the fact that that's actually negative 14 and not positive 14, we make mistakes on that all the time. How about this one? This one should have been 5 times negative 3y, which is negative 15y. But it's also negative y times negative 3y. The negative times negative makes positive, right? So, and then this one, if you have a negative out in front, what number are you really multiplying by? Negative 1, right? If you don't see the 1 there, but there's a 1 there. And now it's the negative 1 property of multiplication, right? So a negative times 2x gives you negative 2x. A negative times negative 11 gives you positive 11. Right? You can just try to be careful on that one thing. So let's see, now we're going to do the 2 that have negatives in them. Try this one and this one. Yeah, just think the negative is going to flip the sign of both terms. Negative 4 plus y. And then the second one?
I got negative 3m plus 15y.
No. Remember, the first, if you do m times negative 3m, that's negative 3 times m times m. And m times m is m squared. So it's actually negative 3m squared. And the next term would be negative 5 times negative 3m. The negative times negative makes positive. And it's 15m. So vocabulary term words here. Terms, coefficients, and like terms, right? Terms in an algebraic expression are that which is separated with additions and subtractions. So if you look in this expression, negative x plus 2x plus 8, how many additions or subtractions are there? There's 2, the 2 pluses. The first negative is just a minus sign, right? So it's actually just the 2 pluses. So that would make how many terms? There's 3 terms. 1, 2, 3. You know, when you look at something like 2x, right, that's not 2 terms. That's 2 factors in 1 term. Okay, so you just, if you see a plus for addition or a minus for subtraction, then you're going to say, okay, that's separating it into different terms. 1, 2, 3. If you have a variable, right, and there's a number in front of it, the word for that is coefficient. Right, this word, C-O-E-F-F-I-C-I-E-N-T-S, coefficient. And if you don't see a coefficient on a variable, what is it? It's 1, right? And the first one, because it had a negative in front, it was negative 1. Right? The next one was 2, was the coefficient. The last term doesn't have a variable, so we call that a constant term. I probably should have put that on there. So this one is a constant. meaning it doesn't vary. Because there's no variable, it doesn't vary. Now, like terms we'll get to on the next slide. Right, like terms have the same variables raised to the same power. So for example, 2x plus 3x plus 4x squared. Two of those are like terms. Which are the like terms?
2x and 3x.
The 2x and the 3x, right? Because they have x's, and those x's are raised to the first power. So those are like terms. The x squared term is not a like term because it's got the variable squared. You can combine like terms. You cannot combine not like terms. So how do I have this on another set? So constants are like terms. So if I had something like 2x plus 3 plus 4, these are considered like terms. Now we're going to get into the properties of exponents a little bit later on. But the truth is, it's not like there's not an x there. There is an x there. But it's raised to the 0 power. And anything to the 0 power is the number 1. So we can consider them to be, it has a variable term, but it's to the 0 power. That's why you don't see it. That'll come up with properties of exponents. So like terms have the same variables raised to the same powers, or they're constants. They can be like terms too. Right. So in this example, it says, identify the terms, like terms, coefficients, and constant terms in this expression. 3x minus 4 minus 6x plus 2. How many terms is that? Right? How many subtractions or additions are involved there? There's a minus and a plus, so that's 3, so it must be separating into 4 terms, right? So there's 4 terms. I don't even think they say that, but that's like the most important thing. Which are the like terms in those expressions? The 3x and negative 6x are like terms. And what are the other like terms? Negative 4 and 2. And the constant terms are negative 4 and 2, and the coefficients are, the two x terms have coefficients of 3 and negative 6. I don't think I got a you trying this. Now, to combine, add or subtract like terms, you combine or add or subtract the coefficients. Right? The variables stay the same, so don't change the exponents when you add up terms. That's a fairly common mistake. And if you also add or subtract the constant terms. So these are procedures for combining like terms. Give somebody a second here. Victoria? Okay. So simplify the expression. What property would we have to use first? Distributive, right? We're still in the section which is all about distributive properties. So yes, distributive. So the first set of parentheses there, that's going to give us what will come out of that? 4n plus, right, you're doing this and this, plus 36, and then what about this, like that? Okay, that's negative minus 6 and minus 3n, right? So negative 3 times n is negative 3n. Okay, now we have to combine like terms. Which are the like terms?
4n.
Okay, the 4n minus 3n, and what about the constants?
36 minus
Right. So what's 4n minus 3n?
n.
See, that's like saying 4 minus 3 times n plus 30, which is 1n plus 30, which is n plus 30. You know, you probably wouldn't have shown those two steps. You would have just said 4n minus 3n is n, and preferably without the 1. So I think the next is for you. You try that. Okay, so it should have looked like this, right? It should have been 5 times 6, 5 times n, negative 2 times n, negative 2 times negative 2. So that's 30 plus 5n minus 2n plus 4, right? Which are the like terms?
That one.
These are the like terms, so 30 plus 4 is 34.
Yes.
And 5n minus 2n would be 5 minus 2 times n, which is
Positive 3n.
positive 3n.
Oh, I wrote it the other way around. Yeah, is that okay?
If you write it like 3n plus 34, what property tells you that that's the same?
Oh, true.
Commutative, right? So it's fine if you do it like that. In fact, most of the time, we always write the terms that have the highest power are usually written to the left. And then you go in descending order of power. We haven't emphasized that yet because at this point we're really only dealing with a few terms. But yeah, this would be considered a standard form right there. And that's kind of preferred. Keep the variable terms to the left. So to spot the mistakes.
Oh. They didn't,
Number 3.
They didn't multiply 5y by 2. Wait. No, they didn't. No. They didn't multiply it. They just wrote it.
Yeah, this here, what is going on right here? What's going on right there?
They have to distribute it.
That's a subtract, right? So that is, you could think of it like plus a negative. So there has to be a negative which is multiplied by both terms inside, which is going to do what in that minus 8? I'm going to make it a positive. That's the mistake. And that's exactly the mistake that we see as math teachers all the time. And sometimes, and you could tell me because sometimes I don't know what, kind of like what's going on in the student's head, but I'll say that sometimes what I'll see here is that students will actually multiply this 5y, like this is a multiplied 5y times negative that. But it's not, right? It's a 5y minus that. That's a different thing. But I see that a fair amount. 5y, trying to think of this like it's a multiply times a negative. And then how about this one? What mistake did they make? Yeah, it looks like they did the first step okay, right? But then the only like terms were those constant terms. So that should have been 6x plus 16. They added them up like they're all x terms. Can't do it. Okay, I kind of like those spot the error things. Okay, then we get into the next section, which was inverse property of multiplication. I think it may not have been this class, or maybe it was the other class. Somebody said we had an additive inverse, but when we had the properties for multiplication, we didn't have a multiplicative inverse, but we do have a multiplicative inverse. The multiplicative inverse is the flip, or if you have a number a, then the 1 over a.
At this time, the golf team and the golf team only may leave for their golf match. Only golf team students may leave the classroom at this time.
Okay, so understand these are multiplicative inverses, and it's an inverse because when you multiply them together, you produce 1. Right? That's the identity element. And usually, I haven't seen that they've come up with this word, but most of the time, the multiplicative inverse we use the word reciprocal. Reciprocal means a multiplicative inverse. Now, here's where it becomes more confusing, because what we just saw just looked like, an integer and then 1 over the integer. But where we really use these things is when it's a fraction. Right? So the multiplicative inverse of the fraction means you flip the numerator and denominator. So negative 6/7, the inverse is negative 7/6. It's negative. The inverse of a negative is a negative, because you need it to be, when you multiply those two, you get a positive. So that becomes really important. I mean, this is still, the inverse of negative 1/5 is negative 5. Negative 5, right. You could flip it, but then we wouldn't show the over 1. Make sense? Okay. So make the multiplicative inverses of those. First one. Negative 1 over 27. Right? What's the next one? Negative 1 over 8, right? How about the next is a fraction? Yeah, it's negative 7 over 4. And the next one is negative 3 over 1, which is just negative 3. And we learned that so that we can learn this, which is when you divide by a number, it's like multiplying by the inverse or the reciprocal. Now, a lot of times I don't find it very helpful. Like if you look at their example right here, 5 divided by 2 equals 5 times 1/2. I doubt that like clears up anything for anybody at that point. You might as well just take 5 divided by 2, whatever way you do that. But when you're dealing with fractions, it really does make a difference. Yeah. Because in this expression right here, if b is 0, then you're dividing by 0. Or even here, if b is 0, you're dividing by 0. And you're not allowed to divide. Right? If you have a set of something, right? If I have a pizza and I want to divide it into slices that each have actually 0 area to them, how many slices will I add up? You can't, doesn't even make sense, right? So that's why you can't divide by 0. It doesn't make sense. And so whenever there's a situation that could have a variable that equals 0, they're going to say, and it's dividing, they're going to have a statement. That's a domain statement to say b does not equal that one number, which is going to make it divide by 0. Yeah, 0 in numerator is fine. 0 in denominator is never fine. So this thing here is, remember that since division and multiplication, division can be written like a multiplication, then the way we deal with the signs of a quotient is the same way as with multiplication, right? If you divide a positive by a positive, you get a positive. If you divide a negative by a negative, you get a positive. If you divide a positive by a negative or a negative by a positive, you get a negative, right? So the rules for the signs are actually exactly the same as with multiplication. Nothing new here. Okay. And then the quotient of 0 and any non-zero real number is 0. So that's a little bit of an added thing in here. But that just looks like this. 0 divided by 8 equals 0. If you get the 0 in the numerator like that, that's okay. I think somewhere along the way, even now, you may have been presented with sometimes saying undefined. If that's not correct. In the numerator, 0 is not undefined. It just means the fraction is 0. Again, pizza analogy, right? If you got a pizza and you cut it into 8 slices, and I give you 0 slices, how much pizza do you have? 0, right? So 0/8 equals 0. And that's not an undefined. 0 is a number, right? It's right in the number line in between positive numbers and negative numbers. It's a very good number. So, again, I'm not going to emphasize this part here, right? The negative 16 divided by 4. First of all, It's a negative divided by a positive, so it'll be negative. 16 divided by 4 is 4, right? Now, does it help to switch that into 16 times 1/4? Probably not. You know, that's kind of the thing we make the mistake with. We'd be better off if it looked like 16 divided by 4 than 16 times 1/4. But when you're dividing by a fraction here, then you really do need to have it written like that, right? So dividing by a fraction is like multiplying by the reciprocal, right? So they changed the division to a multiplication. They changed negative 5/3 to the inverse, negative 3/5. Okay, now it's a negative times a negative, so it'll be positive. The 5 goes into 20 how many times? 4 times, and 4 times 3 is 12. Right? So that's the thing that we've got to learn how to do, because this comes up a lot. In the higher we go in math, you will find yourself having to divide by a fraction, and you'll have to know that means multiply by the reciprocal, okay, or multiplicative inverse. So just to show that, how about do number 6? So number 6, right? Negative 3/8 times 10/3. Right? Turn it into a multiplication by flipping the second number. Don't flip the first number. The second one only gets flipped. Okay, now you can do the just multiply straight across. That's negative 30 divided by 24. But you would have to simplify that fraction. What else could you do?
Can you cancel out the 3?
Absolutely. You can't cancel out the 3's, right? That just gives you 1. You could actually, what's the common factor between 8 and 10? 2, right? You could say 2 goes into 8 4 times, and it goes into 10 5 times. So what's left? 1 times 5 over 4 times 1. And the sign is negative. So you could have done the same thing here. What would have been the common factor you divided out here? It would have been 6. You've still gotten 5/4, negative 5/4. So just, you know, we're a little short on time because of our sitting on the floor for 15 minutes. But how would we change the number 7? How would I write that as a multiplication? 18 times negative 9 halves. And then you can multiply. Any simplifying you could have done?
No.
Does 2 go into 18?
Yes.
How many times? 2 goes into 18 9 times. So this is 9 times negative 9, which is negative 81. Okay. Now this is where it really gets, I see a lot of mistakes with this. And you know, we've moved from the section on distributive to the section on dividing. But this is kind of more about distributive than anything. And to me, it's just like needlessly complicated the way that it's written. But notice that they're saying dividing 36x minus 24 by 6 is the same thing as multiplying times 1/6. And then that's a distributive property. 36x times 1/6, 24 times 1/6. And you can simplify that. I mean, I think eventually we get to the point where we just say, look, if there's more than one term in the numerator and there's one term in the denominator, then you just write it as 36x divided by 6 minus 24 over 6. Right? If there's only one term in the denominator, you can just split it up, divide every term in the numerator by that. That's essentially what they get to, right? 36x divided by 6 is 6x. 24 divided by 6 is 4. So let's take one which is the simple one. How about 12? Just split that up into 2 terms. What do you got? Right? What would be the first step, Drew? Before we simplify everything, that would be what? Negative 6y divided by 3 plus 18 divided by 3. Just write it twice. 2 terms. If there's 2 terms in the numerator, 1 term in the denominator, you can split them up. You can't do that if it's the reverse. If there's 1 term in the numerator and 2 in the denominator, you can't do it. But you can do this. And then what's the negative 6 over 3? Negative 2y. And what is 18 over 3? 6. How about this one here? What are the 2 terms? 2x over negative 4 minus 8 over negative 4. Okay, now what's 2x? What's 2 over 4?
Negative 2.
Yeah, the 2 goes into 4 twice, so that's actually negative x over 2. And negative 8 over negative 4 is? Negative over negative makes positive. Like that. Okay. That was it. So you want to write that down?